1/3 of all aviation accidents are caused by bad weather. Lightning can knock out an aircraft's control system. Hail can smash jet engines to pieces. Despite all precautions, violent weather can reduce even the strongest aircraft to rubble. Weather has always been the aviator's enemy. Every minute of every day, thousands of planes are in flight all over the world. More than 5 million planes take off and land every year. They face the most severe conditions on the planet. In the course of just one flight, a plane can take off from the raging heat of a desert with temperatures over 100 degrees, and then within minutes, be exposed to the freezing cold at high altitude, where it can drop to 50 degrees below zero. Safety is the key issue. Aircraft manufacturers and airlines spend millions of dollars on protecting aircraft from the most severe weather imaginable. Suffer more stress than any other part of the plane. Before this new Boeing 777 goes into service, its wings are put through the ultimate test. This aircraft is having its wings bent to see just how much turbulence they can take. They're designed to withstand a deflection of over 24 feet. Almost 150% greater than the strongest forces they will encounter. The pressure is so great that it deforms the metal fuselage. The new design reaches 154% before the wings finally disintegrate. Extreme edge of research, NASA scientists have even deliberately sent planes into thunderstorms to find out how to protect the fuselage from a lightning strike. The research has paid off. Modern aircraft are extremely well protected from the weather. But despite all this effort, there have been some appalling disasters. Lightning was responsible for the downing of a Boeing 727 in July 1982. Pan Am Flight 759 took off from New Orleans International Airport and climbed 4,000 feet through a severe thunderstorm. Eyewitnesses reported that the tail section of the plane was hit by lightning. Less than 2 minutes into the flight and only 2 miles from the airport, the plane crashed into a residential area. It plowed through 5 blocks of houses, spewed thousands of gallons of jet fuel, and set them on fire. 8 residents were killed. There were no survivors from the 136 passengers and 7 crew members on board. Helicopters are a lot more vulnerable than planes in bad weather. If lightning hits the rotor blades, it can unbalance the motor and destroy the engine. In January 1995, lightning blew the tail rotor blades off a helicopter during a violent storm. It ditched into the sea off the Scottish coast. Despite 35-mile-per-hour winds, the pilot managed to land the helicopter safely. All the passengers and crew escaped without serious injury.
There was a bang and a flash, which we believe to be lightning. It was a surprisingly gentle landing. The helicopter remained upright and stable, and we were able to evacuate the helicopter.
Our job is to cope when this happens. That's what we're trained for. It's a strange job whereby you're trained to do something you hope you never have to do.
If the helicopter had gone in the water upside down, we'd have been villains. It went in the right way up, and we're heroes.
Weather plays a vital part in all aspects of flying, even before a plane takes off. Airport air traffic controllers are responsible for guiding planes through takeoff, landing, and ground movement. They need to be able to see the planes at all times. When poor visibility makes their job difficult, a ground radar becomes their eyes. It tracks all moving vehicles on the ground and all planes landing and taking off up to 200 feet. Even the length of a runway is determined by the weather. The lift on an aircraft wing is far more efficient when it is surrounded by dense air. Air density decreases with height above sea level. A plane taking off from Denver, 5,300 feet above sea level, has to take off faster and over a longer runway than in Los Angeles. And in the summer, air is warmer and lighter than in the winter, so a plane needs a longer takeoff. Once airborne, pilots must be alert to all hazards the weather can throw at them. Hailstorms can cause unbelievable damage. These small blocks of ice are formed inside huge storm clouds up to 10 miles across. The tops of the clouds can tower over 12 miles high, where the temperatures drop to minus 112 degrees. At these great heights, water vapor sucked up by the strong updraft freezes into ice pellets. As the pellets fall, more water droplets freeze onto them. The updraft sends the pellets back up until, too large to stay up, they plummet to the ground as hailstones. If an aircraft strays into a hailstorm, the windows must be strong enough to withstand the impact. But if it gets into the engine, the plane could be headed for total disaster. Hail can smash the fans in a jet engine. The turbine blades shake themselves apart, and the engine bursts into flames. In April 1977, a DC-9 was coming into Atlanta. The pilot radioed he'd struck a severe hailstorm. First, one of his engines failed. Then, his cockpit window smashed. His second engine went up in flames. He attempted an emergency landing on a two-lane highway. As the plane roared down towards the road, its undercarriage struck a car and killed the 4 occupants. The plane finally veered into a grocery store and burst into flames. 68 people died. The massive electrical field surrounding a thunderstorm can create sparks. This may have been responsible for the worst airship accident in history. The Hindenburg was 800 feet long, the largest airship ever built. It was filled with 7 million cubic feet of hydrogen gas. It was May 6, 1937.
Hours late on its trip from Hamburg because of headwind, the Zeppelin had to ride out a thunderstorm along the Jersey coast before heading for the air station and nosing its way to the mooring mast. The wind is bad and the docking is a ticklish one, but it's all a thrill for the crowd of happy passengers eager to land after their transoceanic trip. Slowly the big ship warps in, and the ground crews rush for the mooring line. In another 10 minutes or so, the great aircraft would have been snugly docked. But as the passengers crowded the windows to watch, a roar and a burst of flame near the big tail fin turned the ship into a flaming inferno.
Of the 97 people on board, miraculously, 61 survived. Experts believe a spark created by the thunderstorm ignited a small leak from the gas tanks, triggering the inferno. One of the worst nightmares for a pilot is fog. It can reduce visibility to zero, making airports and runways invisible. Even with the most up-to-date navigation aids, a pilot can still make tragic mistakes. When all their instruments have been working perfectly, some pilots have tried to fly through fog by sight alone. It's thought that this blind vision may have caused one of the world's worst helicopter disasters. In June 1994, 25 intelligence officers in the British military were being flown to Scotland for a secret conference. On the approach to the Scottish coastline, the two experienced pilots flew into a heavy blanket of fog. The pilots apparently ignored their instruments and tried to fly over the fog bank, but they failed and crashed into a hillside, killing themselves and everyone on board. At the crash investigation, there was no final verdict, but pilot error was not ruled out. A new aid has been designed to help pilots navigate through fog. These pilots are being trained to use the heads-up guidance system. The system's computer translates data from the aircraft sensors into easy-to-read symbols. Speed, altitude, and flight path are projected onto a holographic display mounted in the pilot's direct field of view. The pilot looks through the display, not at it. The numbers and symbols are focused at infinity, so pilots can keep a lookout for the runway. For airlines that operate in bad weather, systems like this keep them flying. Without them, they would be grounded with long delays and financial loss. Even with the runway barely visible just 50 feet above ground, the pilot can make a safe landing. Fog guidance systems had not been invented when tragedy struck at Tenerife Airport in the Canary Islands in 1977. At 5 p.m. on March 27th, a KLM 747 taking off in thick fog collided with a Pan Am 747 taxiing along the same runway. All 244 passengers and crew on board the KLM flight were killed instantly. Of the 386 passengers and crew on the Pan Am jet, only 48 survived. Fog had caused the worst crash in aviation history. Hidden inside thunderstorm clouds are winds so powerful they can rip the wings off a plane or simply smash it to the ground. These violent updrafts and downdrafts are called microbursts. The strongest downdrafts, called downbursts, are the most dangerous. Air rushing down smashes to the ground and spreads outwards as a high-speed, turbulent wind. A sudden change of wind direction from a downburst can cause a plane taking off or landing to suddenly lose airspeed. If it fails to regain enough airspeed, the plane will stall and plummet to the ground. In 1985, Delta Airlines Flight 191 was approaching Dallas-Fort Worth. As it descended out of a thunderstorm, it was hit by a microburst seconds before reaching the safety of the runway. The massive 60-mile-per-hour downdraft slowed the aircraft's speed from 170 to 110 knots and slammed it downwards. It skimmed a road, hitting 2 cars before crashing into a water tower and exploding. "36 people were killed. Miraculously, 30 escaped, some completely unhurt. The winter months bring a whole new set of weather problems for aviators. Pilots and airport authorities are faced with the dangers of snow, freezing temperatures, and ice. Ice is the single biggest weather killer in modern aviation. If ice coats an aircraft, it weighs the plane down and changes the aerodynamic performance of the wings. The plane can simply drop from the sky. So pilots have to look out for ice building up on their aircraft. Temperature decreases 7 degrees for every 1,000 feet altitude gained.
Positive range.
At normal cruising altitudes, the temperature can be as low as -50 to -70 degrees. The most dangerous form of icing occurs when a plane flies through supercooled water droplets. These are drops of cloud or rain which are still liquid, even though the surrounding temperature is well below freezing. If these drops hit the plane, they freeze instantly, giving a hard, transparent coating of glazed ice. There are no instruments which can detect ice, and even the best forecast can miss clouds that might deposit it.
Looks like we're picking up a little ice on the leading edge of that.
Okay.
Light ice.
The only prevention in flight is to heat the leading edge of the wings.
Good inflation.
On the ground, it's vital to spray aircraft with de-icing fluid before taking off again. The fluid, a form of antifreeze, melts any ice that has accumulated on the aircraft. This simple operation can save a plane from disaster. Ice on runways can pose another serious threat. On January 23, 1982, a DC-10 carrying 190 passengers skidded off the end of an ice-coated runway at Logan International Airport into the freezing cold waters of Boston Harbor. By an amazing stroke of luck, nobody was killed and there were only minor injuries. Ten days earlier, an Air Florida jet leaving Washington, D.C. National Airport, coated with a heavy load of snow and ice, stalled on takeoff. Unable to climb fast enough, its tail section hit the 14th Street Bridge across the Potomac River, killing 3 people in their car. The stricken plane tumbled into the icy water. The 737 broke into 3 sections. The nose and main fuselage plunged straight under the surface, killing everyone inside. The tail stayed afloat for a short time, and a few survivors were thrown out into the river. Millions of Americans watched the rescue attempt on live television. The water was so cold, the survivors became numb and began to freeze. Unable to watch the helpless woman any longer, an onlooker plunged into the icy water. The woman was almost unconscious, but he managed to drag her to safety. The helicopter pilot risked the lives of himself and his crewmen. He settled his craft almost on the water, while the crewmen clambered out onto the landing skids to reach another survivor. Of the 83 on board, just 5 survived. Has caused some of the worst disasters in aviation history. But these tragedies are, fortunately, extremely rare. Accurate forecasting and technological advances help us cope with all kinds of weather. In fact, aviation is now the safest form of travel.
Coming up, the Earth is gradually releasing long-held secrets from the age of the dinosaurs, with a little help from modern science. Join the archaeological adventure as TLC uncovers the mystery of dinos in the snow on Paleo World next.